Elastic collisions. An elastic collision is a collision in which the total momentum and the total kinetic energy are conserved. Most collisions are neither elastic nor perfectly inelastic. Momentum and kinetic energy are conserved in an elastic collision. So M1 V1I plus M2 V2I is equal to M1 V1F plus M2 V2F. When we're talking about using energy, so the first part of the equation was momentum, the second part is energy, 1/2 M1 V1I squared plus 1/2 M2 V2 squared is equal to 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. All right, so let's do an example. Elastic collision example. A juggler can keep as many as 12 identical balls in the air at one time. Suppose each ball has a mass of 0.20 kilograms and two balls have an elastic head-on collision during the act. The first ball moves away from the collision with a velocity of 3.0 meters per second to the right. The second ball moves away with a velocity of 4.0 meters per second to the left. If the first ball's velocity before the collision is 4.0 meters per second to the left, what is the velocity of the second ball before the collision? All right, so the givens for this problem are M1 is equal to M2 is equal to 0.20 kilograms. My velocity 1 initial is 4.0 meters per second to the left. My velocity 1 final is 3.0 meters per second to the right. My velocity 2 final is 4.0 meters per second to the left. I'm looking for the velocity initial of the second object, which is the juggling balls. We're going to start with this equation. M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. Okay, since the masses are all the same, we don't need to worry about them because they cancel out. Now, I'm looking for the V2 initial, so I want to get V2 initial by itself, so I'm going to subtract the V1 initial to the other side. So V2 initial is equal to V1 final plus V2 final minus V1 initial. So now I can plug in here and I get V1 final is 3.0 meters per second. My V2 final is minus 4.0 meters per second. And my V1 initial is positive 4.0 meters per second. So when I calculate all of that, I get V2 initial to be 3.0 meters per second, and it is moving to the right.